So I've also gotten a couple questions about problem number 10. Problem number 10 was taking this original shape, which I just copied down off of the out of the book, and I put it on this graph. Now, I have heard from some of you that you don't have graph paper. A lot of your graphs can be done in Desmos if you want. You probably want to go ahead and save them. Remember, it's really easy just to go over to the left-hand side and name the graph. And when you name the graph, it'll save it. But I also had some concerns. People were saying that they didn't have patty paper. You can do this problem without patty paper, but actually a lot of your parents probably have waxed paper in the kitchen, and that actually is going to work even better than patty paper because it's easier to see through. So what I did is I have my original picture here, and then I put a piece of wax paper down, and I went ahead and marked the origin of the graph right here, and then I relabeled everything on my wax paper. So the first thing that we had to do is rotate 180 degrees. Remember, when you're rotating 180 degrees, it doesn't matter which direction you go. So I am going to do 2 turns. That makes it rotate 180 degrees. I go ahead and reline up my origin to make sure it's matched. For those of you who don't have that ability, you can actually just take the graph that you have and rotate your paper 180 degrees and relabel the axes. Now you actually have this square down here in the 3rd quadrant. Okay, so that might be just as easy to do. But after I have that rotated, I have this graph right here. And then the next thing that it says is it then wants you to, it wants you to reflect it across the x-axis. So here's my x-axis. The reflection would mean that I really want a mirror set up right here. So couldn't I just fold my paper in half at the origin? And now I've moved this shape all the way back up to there. And so the question for part B wanted to know what the coordinates of C prime was. So C prime would be this shape down here. So the coordinates for C prime was actually at, must be -5, -8. Just noticed I didn't have a negative sign on my 5 right there. And then the coordinates for D double prime would have been when we flipped this up here like this. What you actually will probably notice that this shape is actually just a reflection of my original shape. So D double prime, actually, maybe it's not. I don't believe it is. D double prime is over here at -7, 1, 2, 3, 4, -7, 4. So those are the 2 coordinates that they're asking for on this problem. You guys go ahead and label your graph and draw it if you want to. If not, it probably is easier, but because I didn't have it, I'm trying to go a little fast, I didn't do that. Part C is the most important part of this question, I believe, and it says, what's the area and perimeter of ABCD? So it wants the area and perimeter of this original shape. Well, it's kind of interesting as we're looking at this. We don't know how long this line is right here, but what we do know is that I can actually make a right triangle right here. My right triangle has a height of 2, 1, 2, 3, 4, and a base of 4, or you could say it the other way around. So if I know that, I know that the length of AD is going to be 2 squared plus 4 squared is going to equal the length squared. So I know that the length of AD is 4 plus 16, or the square root of 20. I can do that same thing for each of my sides. I know that this right here is a 2 by 4 triangle also. And if I actually look carefully at it, all 4 sides are the same. So all 4 sides have a length of the square root of 20. that does go back to the question A, which asks what shape is this? And it turns out that the shape is a square. I know that these are 90-degree angles right here because I know that the slope of CD is actually 4 over -2. And the slope of AD is 2 over 4. So my slopes are opposite reciprocals, which means I have a 90-degree angle, which proves that this shape is a square. So that was actually part of question A. Going back to my area and perimeter, for my perimeter, I actually have 4 sides that are at the square root of 20. So we could just go 4 times the square root of 20, which on my calculator, I found out that 4 times the square root of 20 is approximately 17.89 units. We also need to figure out the area. It turns out the area, it's a square, so the area is the side length square, so we're going to take the square root of 20 and we're going to square it. Well, if you're going to square something that you're taking the square root of, those are inverse operations. So we're actually just going to get 20 as our answer, because we could say square root of 20 times the square root of 20. Well, that is 20. So that's going to be 20 units squared. So I hope that helps you with question 10. There's actually going to be quite a few more questions in this chapter that are similar to this. Remember, if you have wax paper, that's going to be helpful, or just start rotating your paper as it is and relabeling your graph would work also. Hope that helps.